Good morning, Synchro. Welcome. All right. Put that there. Got some water. These are the notes that we were working on. So now we're going to talk about today this and pointer objects. Okay, it is 11:20. I am going to check the actual stream here. See how many people we got. And we've got a lot of you, so we're going to get started. So happy Friday to you. Weekend coming up. I know it's probably not going to be a very fun weekend. Because of the assignment, but remember the assignment is small. All right, it should take you, if you're a master at inheritance, 15 minutes. If you're not, 30 minutes. It really will not take you very long at all. If you haven't finished assignment 2 yet, maybe you're still working on that today. I know a lot of you guys got it finished up. And I know a lot of you guys were cutting it close too, so just keep that in mind. Assignment 4 will be releasing soon. Assignment 4 is going to go up today. I will pick a due date sometime later next week, so you can kind of allocate your time appropriately. But I would say if you get started on assignment 4 this weekend, it might help you for the test. Yeah, School Plus Work is hard. I know it all too well. But we are an accredited university, so You know, we can't cut corners, unfortunately. So yeah, that's kind of it, you know. So you might be studying this weekend. That review did go up, but today should be a pretty easy day. It'll be a pretty easy day. I just need to cover these two things that you see on the screen right now. We need to go over this, and we need to talk about pointers to objects. And then after that, we're done with pointers. And you have everything that you need. So then we're going to go straight into that review. I'm just going to go through that review question by question. We're going to answer them. I would appreciate some participation for that, but we will keep it moving. So, you know, I won't wait too long for you guys to, you know, answer. But if you do need me to stop and go over something, I will. After today, I will upload all of the answers for that review sheet. I will upload all of the answers so that you can reference them. And that's that. So, does anyone have any questions about, I guess, assignment 3 and or anything we went over yesterday? So I have talked about the test format a few times already, but I will say it again, that it's going to be between, you know, 24-ish to 30 some questions. There's going to be questions from everything that we have gone over so far, which means function overloads, classes, inheritance, and dynamic memory. There are going to be a hodgepodge of questions. That's multiple choice. That's short answer. That's short coding. You know, definitions. Pretty much any question you can imagine I could ask you about coding, you're going to be answering it. But they're all going to be shorter. And then the very last question is a full program. You have to write a full program for the very last question. So that's that. And like I said, the test review is not the same format as the test. It's only, the test review is only there to prove that you know about them. When you actually get to the test, you're going to have to be a critical thinker, for the most part. So that's that. I'm not going to review this stuff that I went over yesterday because I want to spend as much time on the review as we possibly can. If you need a review for this, please watch the YouTube video. I think yesterday I did a pretty good job going over just this stuff. This is pretty much all we covered yesterday. So if you need a review, please watch that video. So now we're going to talk about this. I've mentioned this before. Does anyone remember what I said? It's in the notes somewhere. Does anyone recall what this is? Can you please give me any kind of thing that you think it is? Make it a little bigger. And once again, I have talked about this quite a few times. Yeah, so Synchro says this pointer. It is a pointer. That is correct. Does anyone remember specifically what I had said about this in the sense that what is it pointing at? Does anyone remember what it's pointing at? I'll give you a few moments for that. And then we're going to do an example. So I'm going to kind of get started on that. It is pointing at an object. It is pointing at an object. So I'll give you that. So for today, Speaker says non-static. I would not associate static. It is, well, you know, you're right. It is non-static. This is non-static. And I'll explain that. You are correct about that. Though, it is going to be a little bit confusing. So let's pretend I'm going to add... Do you guys remember this? I mean, I assume you would. If you need a review, please go look. This is a class that we made yesterday. It's called int container. And it's basically an integer variable but it can be empty, all right? So inside of the container, it could contain an integer or it could be empty. So that's why we're using a pointer, and we kind of went over these things yesterday, right? We talked about some constructors, and then we talked about this rule of 3 thing, right? And this was pretty in-depth. You can see down here we talked about that stuff. So I'm going to build on this today. This is the only example we'll do, and I'm just going to build on it. So I'm going to add a member function to help explain what this is. So I'm going to add this function called void add, and it will take another int container. Say maybe a const int container, and it's going to be the, I don't know, maybe it'll just be container C. All right. And what this function will do is it will add C to whatever object we're working with. All right, and this is how we're going to talk about what this is. So first I'll give you some notes. This is a keyword when being used in classes. This is a pointer to the object that the non-static function was called from. All right? This is a test question. So when I ask something, I say, what is this? If you answer it this way, I will give you full points. It is a pointer to the object that the non-static function was called from. So we'll start with that. It is a pointer. So let's kind of get into this example here. So I'm going to put a definition for this somewhere. Let's put it down here at the very bottom. It's going to be our add function. And so basically what this does is it's going to take C and add it to the object, right? So let me go into main. And I'm going to make some int containers. All right, so actually we have IC1 and IC3. They are both equal to 10. So all I'm going to do is I'm going to take IC1 dot add IC3. And so what does this look like as an expression? Why are you mad at me? Hold on one. This is not a pointer. I'm sorry, everybody. I want this to be a. I want this to be pass by reference. So this is going to look like this. IC1 is equal to IC1 plus IC3. All right. That's what this function does. That's what this function does. And so what I'm going to say here is let's do some couts. I'm going to say address of IC1. This is printing from main. And it's going to be equal to, if I want to get the address of IC1, what do I put here? Let me ask you guys that. You guys should know, if I want the address of IC1, what do I put here? Might be a little behind here, but we've got a test coming up. We've talked about this for 2 days already. You guys can answer this, please. It's in the notes. I want the address of this variable. How do I get it? That's a dereference operator. We dereference pointers. So that's another operator, but what's the operator to get the address of this variable? Synchro's close, but it's not star. What is it? Yes, it's that one. If I want the address of IC1, I call and ampersand IC1. All right, this gives me the address of IC1. Now, guess what? We said that this, all right, look at the notes here. This is a pointer to the object that the non-static function was called from. So let's look at a few things. Add, this is non-static. Now, if you remember from the Discord, what did I say about static and non-static things? Non-static members are always associated with an object, all right? So notice here, this is a non-static function, and it's associated with this object, IC1. So this is a pointer of these objects, IC1 and IC3. This is a pointer to what? Which of them? Once again, this is a pointer to the object that the non-static function was called from. So what is this talking about? Is it talking about IC3? It's talking about IC1. So it goes right. It's talking about IC1. So in here, if I say cout this, I should see the exact same address that's printed out here. So I'm going to do that. And we're going to run it. I'm going to put IC for int container. All right, so that should work. I'm not sure why it's angry. This is a non-static member function. You goober. That is non-static. Yeah, what are you talking about? Well, let's see what I missed here. Let's pull up. Bobby was not working today for some reason. You guys must have broke it last night. Let's see if it's working now, because I really don't want to use another server. Come on, Bobby. What did I ever do to you? It shouldn't. Yeah, Bobby is not okay right now, and I'm not sure why. Maybe it's me. Sally was also not working, so I'm going to use this server. Please don't use this server. I'm going to make it so small that you can't see which one it is, hopefully. I might have to restart my MOBA. No, we're in. Well, I can't hide it from you guys. I'm not going to lie. I can't hide it from you. Please don't. If you have to use this server, you can, but please refrain from it at all costs. I would try Cardiac first. But here we are in our test folder as always. I'm going to pull this same file in here. I'm going to try to compile it. I don't think Sally is working either, Synchro. I think if Bobby's not working for me, Sally is also not going to work. Yeah, I don't know why. This is a non-member function. Why? I wonder if cout is being annoying. But I think it should work here. Let me triple check. This is non-static. I even said so here. This is not a static function. Oh, you know what I'm missing, guys? To answer your question, Hulu, I'm not sure what's going on. Does anyone want to try to connect to one of those servers right now and tell me if they're successful? If they're not, I'll talk to the IT team. I'll send a little thing. I will send a message to them, and I'll say, hey, what is going on? What's going on today, guys? We've got programs to do. All right, so I fixed it. You can't connect? All right. So maybe I'll talk to them after class. All right, so I fixed it. Thank you guys for checking. And I'm going to show you that this is the address of the object that the member function was called from. There you have it. So notice that I called add. And so from within this member function, I printed this. Notice that it's the exact same address of that object. All right? They're the same thing. Same thing. So guess what, right? So this is when I say things like this. This is when I say, you know, if I'm referring to I pointer, right? This I pointer belongs to this object. This belongs to IC1, belongs to this. And then if I do C dot I pointer, this belongs to the parameter, right? So those are the difference. Those are the differences. So now I'm going to kind of speed through this. But here's my question for you. Well, not yet. Not yet. So if I want to add these values, let's first consider if the containers are both empty. How do I know if the containers are empty? How would we check for that? We've been checking for it a few times already yesterday. Nope. It has something to do with this. How do we know the containers are empty? It has something to do with this thing. Yes. Attacker is right. If it is null pointer, then it's empty. If it's not null, then it's not empty, right? So here's what we'll say. We'll say if we're going to do a few checks. So we're going to say if I pointer does not equal null pointer and C dot I pointer does not equal null pointer. Here's what I'm going to say. If they're equal, right? So this object is empty and the parameter one is not empty, then I'm going to say this. I'm going to say I pointer is equal to a new int. Make space for a deep copy. And then we'll check, let's see, we're going to check one more. Let's check to see if this object is not empty. And I'm going to check to see if the other object is empty. In this case, I'm just going to return. Because this is like, say, 3 plus empty. I want it to be equal to 3. All right? So this is like num plus empty. And then this one is empty plus num. It's going to kind of act as 0, all right? So if it's empty plus num, then I'm going to want to allocate some memory for that. But if it's num plus empty, then we don't have to allocate any memory, and we actually don't have to do any addition. So I'll just return. Else, they're either both null pointer. Let's check for that. If they're both null pointer, then let's just return. I guess I'll do an OR statement. I'm going to make this vertical. I'm sorry for the ugliness. I'm going to make it vertical, though. All right, so either it's num plus empty or empty plus empty. If either of these are the cases, then we'll just return. Once again, I'm sorry for the verticalness, but you can kind of see what's going on here. And then lastly, we know that we've made it past all of those checks, right? At this point, we know. I'm glad that you like it vertical. I'm a database administrator. I type SQL all day. I don't know if you've ever heard of that. And that language is the most vertical thing ever. And so I'm kind of vertical by nature. But something about this kind of bugs me because Do you see that this bracket here, this bracket is indicating that it belongs to this if, but there's like this gap here? That's why I don't. That's why I'm unhappy. But things that are vertical do make me happy in general. So at this point, we know that both of them are not empty, right? We know that both are not empty. So at this point, we can do something like dereference I pointer at this location, and we can say it's equal to the dereference version of this I pointer plus the dereference version of the C.I pointer. Now there's one more thing I forgot to check for here, all right? And it's that I'm gonna wanna initialize this to be 0 just in case. Init it. We definitely want to initialize this. In the case that we are doing an empty container plus num, let's make sure that we initialize it to 0, so when we get down here, we don't have any problems. And that does that, all right? So we're pretty much done at this point with this example. And so we're actually kind of wrapping up here. I just have to introduce one more operator to you guys. So pretend this. Let's pretend I had a pointer to an int container type, all right? This is going to be IC pointer. All right, this is a pointer to an int container, all right? So at this point, it's probably empty. Let's make sure we know it's empty. And then if I want to allocate something in there, what do I say? Can anyone tell me? What am I going to put here? If I want to allocate something into that pointer for an int container, what is the code for that? And I don't care if it's empty. I don't care if it's 5. I just want to know what you think. Recall, this is kind of day 2 of this stuff, right? So we've been day 3 of it, actually. So if you have an idea of what to do, it's probably right. How do we allocate stuff into pointers? We've done it in this example a lot of times. We did it in our other example. It's in the notes. What function do I call here? What function returns an address for this pointer? There it says new, right? That's what we call. I'm going to say IC pointer is equal to new. And I'm going to do this. Does anyone have an idea of what happens here? No, you got it right, Cherry. I was just asking you guys to allocate something into this pointer. What happens here? What do you guys think? It calls the default constructor, right? All right. So keep that in mind. 420 is right. This calls default constructor. If I want to put something in here, like 10, this calls the parameter constructor. This calls a constructor. So very good. That calls a constructor. Now, let's say, notice I have, say, IC1, and I want to call something from it, right? Add, for example. If I want to call add from the pointer, what code do I type? Now you guys have enough information of this, okay? You have enough information to do this. Notice this is going to say I'm angry, and that's fine. I want to see if you can use your brains here a little bit. If I want to call add from this pointer, what do I have to do? This one's fine, all right? This one is fine. I'll show you. This one is okay. I just have to put something in there. But if I want to call add from here, what do I have to do? You don't have to give me the code, but what do we usually have to do for pointers before we do anything with them? Maybe that's a little bit of a hint. Scope resolution, we could, but I would say attacker is more right. We have to dereference it. We have to dereference it first. So I'm going to do this. All right. Now that's annoying, isn't it? That's pretty annoying. Dereference it before you call the dot operator. So this is a test question. All right. Keep in mind, pointers to objects. How to access members inside of a pointer to an object. First, dereference it. Second, dot operator, right? So what does that look like? Here's an example of that. You're going to take star object obj pointer. You're going to dereference it, and then you're going to call the dot operator on it. Something like that. Now I ask you, is there an easier way to do this? Yes, there is. So there's a new operator here. And here's why this operator exists. It's not required for C++. It's just kind of an ease of life for us. As C++ progressed, the creators and other coders found that they were doing this all the time. Dereference dot, dereference dot, dereference dot, over and over and over again. And they said, this is so annoying. Can we change it? Yes, we can with this operator. We call this the arrow operator. It's the exact same thing as this. It's the exact same thing as that. It dereferences. And then it dots. It dereferences, then it dots. So at this point, this is just a fun question. How many operators dereference objects at this point? Can you guys take a guess at that? Of all the operators we've learned, how many of them actually dereference the pointer? There's obviously one here, right? But do you guys have any guesses of others? 3, right? There's exactly 3. So what are the obvious ones, right? Obviously this one, I just covered it. And this one dereferences. What's the third one we're talking about? What's the third one that we're talking about? Obviously the arrow does it. Obviously the star does it. And the brackets, right? That's exactly right. Thank you for paying attention. The brackets also dereference our pointers. Exactly right. The square brackets, that is. Not the curly brackets, but the square brackets. So if I didn't want to do this, I could do this. All right? Does this confuse anybody? Please tell me if this confuses anybody. They do the same thing. This is the same as this. So now I'm just going to point one thing out. And I'm not trying to make anyone sad. But it might help you with your objects in classes. I know a lot of you guys are still kind of confused about how classes work. And so, for example, maybe in your program with your sort deck function, right, on assignment 2, you go, man, I need some cards. Let me declare a deck variable deck, and then let me access those cards within the deck. I saw that multiple times for this assignment. And the problem with this is, as long as the function is non-static, you already have access to some cards, right? So you actually don't need to declare an object. And so if that's ever confusing, and the confusing part is this, right? The most confusing part is this, that in some of these functions, you have an I pointer, and you might have a C dot I pointer. And you're like, which one am I supposed to be using? Why do I call a dot operator here? And why do I not have to call a dot operator there? Well, if you're ever confused, your function will work exactly the same way like this. Now I'm going to make this program super ugly real quick. But the point that I'm trying to make to you is that it's the same thing. So notice in a way you kind of do use dot operators for this. But this I pointer belongs to the this object, and this I pointer belongs to the parameter object. So if you're ever confused about that, this kind of thing works. You can reference this. You can reference this, right? You can dereference it. You can call the dot operator and access the members. And then if it's a pointer, then you can dereference it again, right? Also, this works. I'm saying this way too much, but that works as well. All right. So does that make sense that as long as the function is non-static, you have access to the members in that object, and the reason you do is because of the this pointer. And if you're ever like, why do I need a dot operator to call this one, but I don't need a dot operator to call this one? Go ahead and try this. Try this out to see if it works. And that's it, all right? That's us wrapping up this whole chapter on pointers and dynamic memory, all right? We're going to move on to the review now. We've got about an hour for it. So before I move on from this, does anyone want to talk about what I'm doing here? Is this sufficiently confusing anybody? Please let me know. I will upload this example and the notes. Cherry asks, can I show how to use the arrow again? Yes, I can. I'm just going to use these examples, all right? So I have a pointer to an object, all right? That's what this is. I have a pointer to an object. And I want to go inside of that pointer to the object, and I want to access this member function. I want to access this member function. So in order to do that, I have to call the dot operator on a dereferenced version of the object. So actually, I think you understand that, Cherry, because I'm looking at your second question. And the reason for that is this. What is this? I mean, not what is this, but what is this pointer here? What type is it? Can you tell me what type that is? What is that type? I mean, it's pretty obvious by its name, but I still want you to tell me so I can make it click for you. Please. And I'll scroll up if I have to. It's an address, right? So, yeah, this is sufficiently confusing. But what am I doing? I'm accessing iPointer, which is an address, and then I'm dereferencing that whole thing. I'm dereferencing the whole thing. So it would actually look like this. In that here's why it's there. If I got rid of this, I would still have to dereference that pointer, right? And the only point that I'm trying to make to you right now is that this pointer here belongs to the object. It belongs to the this object. And so if you ever... So that's a great question, right? So can anyone tell me what is this arrow? What part of this expression, of this whole expression, what part of it is this arrow dereferencing? This is an important question. Does anyone know, or can anyone tell me right there what that arrow is dereferencing? I'll give you a few Jeopardy moments. Synchro says this, right? It's dereferencing this. So it dereferences this, right? what this, the keyword, right? What is this? Well, this is a pointer. Where is it? It's a pointer to the object that the non-static member was called from. All right, so that's dereferenced. But is this I pointer, is this dereferenced yet? The answer is no. So this is dereferencing something, but it's dereferencing this. And then Cherry, this is still a pointer, right? So I dereferenced an object and I pulled out a pointer. That pointer still needs to be dereferenced. That pointer still needs to be dereferenced. So notice here, here's the first dereference, right? This is me not using the arrow, right? This is me not using the arrow over here. Notice I first have to dereference this, and then now I'm dereferencing the other pointer. So, very confusing. Very confusing. I totally understand. Next week, we're going to spend some more time on it. On the test, the kind of question you'll see about this is just, what is it? All right? So don't try to package that in your brain. Don't try to package whatever this is in your brain. Whatever this is, this whole expression, nothing like this is going to be on the test, all right? Not yet, at least. Maybe the final, but nothing like this will be on the test. The only thing you need to remember is what is it, all right? It's a pointer to the object that the non-static member was called from. And then I'm going to ask you, what is this thing? What is the arrow? What does it do? Well, it does this. All right? So as long as you're all okay with that, it's review time. Let me know if I need to go back. It's review time, though. So let me pull it up. Now I'm going to ask you guys these questions. I want you to answer them. I'll tell you what part I want you to answer. If it's going to take a little longer, then I might just kind of speed run it. But for now, let's see how well we can do, because I want to try to get through all of it. I think we have enough time as long as we keep up to date here. So can anyone, let's get started right away. Can anyone tell me what defines a function overload? And I don't need a complete sentence. I just want to know, do you guys remember what a function overload is? What are the things that I look for? I'm gonna start setting timers just so we can keep moving along here. Multiple functions that have the same name, but what else? There's one more thing there. Tell me what else. What else do I need? There's one more thing that's specific to that. Different parameters, right? That's exactly right. A function overload are multiple functions within the same scope that have different parameters. They could have different type. They could have a different type. But the main idea is that they have different parameters. So let me ask you this. We're going to kind of step out of the box here. Yes, Ali says different parameters to differentiate them. That's exactly right. So we're going to step out of the box here. We're going to jump back up to inheritance. So I ask you, two functions are contained within a base class and a derived class. They have the same type, name, and parameters. Is that a function overload? Cherry says override. Okay, she's ahead of me. So this is no. The answer to this is no. What about this one? Two functions are contained within a base class and a derived class. They have the same type and name, but different parameters. Is this a function overload? What do you think? Yes, it is a function overload. If two functions are contained within a base class and a derived class, they are within the same scope. They have different parameters, though, so it's a function overload. All right, what about this one? This one's probably easier. Two functions are contained within the global scope. They have the same name, but a different return type and different parameters. Is it a function overload? I mean, that one is pretty obvious, right? You guys probably already answered it. Number 4 is yes. All right. What's the difference between a struct and a class? Anyone tell me? And while you're at it, if anyone wants to jump on this one too, what is the rule of thumb for using a struct or a class? Private, but private what? I did say I don't need complete sentences, but we do have to specify some things. Structs are public by default, classes are private. That's exactly right. And what is our rule of thumb? What's the rule of thumb? At least one of them. Class, well, Z, structs also have the ability to be private, all right? Structs and classes are exactly the same. Structs and classes are exactly the same. It's just by default. If you don't specify a member access specifier, if you make a struct up here, if I say struct this, struct my struct, if I don't specify something, everything is public. But the moment I do this, the struct has a private variable. All right? So structs and classes are exactly the same. It's just the default. Yes, Z, that is correct. Cherry says for number 2, what is the rule of thumb for using a struct or a class? It says you have to use functions in order to use the private members in a class. That's a correct statement, but my rule of thumb is that if you're going to have functions in your object, you're going to want to use a class. If you don't have any functions, I want you to use a struct. So if it's completely data, just variable, 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 please use a struct. If you've got variables and functions, please use a class. All right, I'm just going to say this one, right? This one should be what we know. What does it mean for a member to be public? It's accessible to everybody, right? It's accessible to main, it's accessible to the global scope, at least as long as the object is within the global scope. And private variables are not accessible to anybody. They're only accessible to the class, all right? You guys should know that one kind of by heart at this point. Private variables are only accessible to our class. Public members are accessible to everybody. All right, so assume you have a static object for a class in main. Now, listen, this is not a static member, all right? Remember, I'm telling you not to get confused, which is hard, all right? When I say static object, I'm not referring to a static member, just an object. What operator would you use to access? Cherry's right. Use the dot operator, right? Here's an example of that. Where is it? Here it is, right? IC1 is a static object. Static. It's a static object. How do I access it? I call the dot operator. What 3 classes have you guys used before? Provided to you in the standard template library. I know that you've answered this before. What 3 classes? You've probably used more than that, but just give me 3 of them. Z said in file, right? Vector, that's correct. String, yes. Those are the 3. I don't think cout is an object flyer. Just so you know, cout is an object. It's not a type. So I think what cout is, just so you know, just like you might do. Well, so I haven't included the library, but there's a class called ostream cout. Cout is the object of that. Now it's mad at me because cout is something. Well, it says no default constructor exists, but just so you know, cout is the object. This is its type. So you're close. You're close. But everyone else, you got that one. Why would we have const defined for a member function? And also, what is the term for a member function that is not constant? All right, so answer these two questions. Why would we have const defined? And what is the term for a function that is not const? And if you guys are looking ahead and you want to answer any of these, just put the number next to it so that I can see it. All right, I'll let you jump ahead if you want. Please just put the number next to it so I know which one you're answering. But for now, I'm going to wait on number 6 here because we should know this one. We spent some time on it. Cherry says, so that the object is not altered in the function. That is correct. So const functions are not allowed to alter the object. Exactly. What was that fun, I'll give you a hint, X-Men. What was that fun term we used for functions that don't have constant in them? The hint is X-Men. You remember that? Mutator, right. That's right. It's a mutator, all right? So any function that does not have const on it is mutator. It mutates the object. All right, answer this one. Why would we have static defined? Why would we have static defined for a member function or variable? Now, maybe not why, but what does it mean? If you can't answer why, that's fine, but what does this mean? What about the member is distinct? If the member is static, what about it? What's the key thing I'm looking for? This one's a little harder, right? I'm going to say no to Z, no to 420. Cherry, you're close. Synchro, no. Flyer is the closest. It's shared by all objects. A static member, here's what will get you full points on the test. If a member is static, it means that there's only one for all of the objects. Do you guys remember me saying that? A static member is shared by all of the objects. So if we have 32 players, and we have that one static member, right? This is in assignment 3. We have that one static member that says player count. If we have 32 players, they all share this one member, this one static member. So in a sense, Synchro, you're right. All right, I'll give it to you. There's only one of them. All right, there's only one address for this static variable. But also, the most important thing to remember is that this object is shared by all of the objects. There's only one of them. So now what's the opposite of this? What is an instance variable? You can kind of just reverse. You can kind of just reverse what Flyer said, but I want to see you say it. What is an instance variable? Put it in your own words, right? If I ask you on the test, what would you say to this question? I'll give you a few more moments here. Attacker says each variable has its own address. They are unique. Let me see. So attacker, I would say that's correct, right? Each variable will have its own address. But not quite what I'm looking for. Synchro says only in an instance it's available. That's true, but I feel like it's not quite there yet either. A variable that has a copy of each instance of the class. Well, maybe. Here's a good way to put this, and this is how I'll answer it in the review answers that I post. An instance variable is a variable that belongs to the object. So each object has their own set of variables. Each object has their own set of variables. So if we look at this, Notice that this is an instance variable, all right? I pointer is an instance variable. Y is an instance variable. The reason is because IC1 has its own pointer. IC2 has its own pointer, but it's different. IC3 has its own pointer, but it's different. This object here, this has its own pointer, but it's different. So down here, at this point, I should delete this, by the way. Oh, tell me, I'm stepping out of bounds here. Does anyone know what's called here? Sorry to tear us away from that. Just want to know, what is called here? What is called at the delete? Okay. 420, you're right. You're right. I need to do this to avoid the alias. Very good. Very good. Very good. But what is called? What is called at this moment? Aside from delete, what is called? So Flyer, you're right. But aside from that, what else is called? This is an object, remember? I just want you to associate them. So someone got this one, right? Remember, someone got this one, right? So if you're using this as a hint, when we call new, what do you think is called when we call delete? The destructor, all right? Remember that. The destructor is called. Notice we're releasing it. This is the difference between dynamic and static memory, all right? At this point, we're releasing it. We say, all right, call the destructor here. So I'm sorry that I stepped out of bounds. Once again, since we're pretty fresh on this kind of stuff, the test will not be too heavy on like that kind of question. All right, I will ask you some basic pointer things, but we're gonna spend more time on this next week. All right, we're really gonna we're gonna really nail this stuff into your head. But on the test, you can only expect some of the basic pointer questions. At least the ones you'll see on the review. We'll go over them. You'll see kind of what I'll ask you. All right, so I'm happy you guys understand what this means, right? An instance variable is a variable that belongs to the this object. It's a variable that belongs to the object. Static is a variable that belongs to the class. It belongs to all objects. Instance variables only belong to objects. So now that we've settled that, many of you struggled with this. Do static member functions have access to a class's instance variables? Yes or no? Now I just defined both of these for you. So with some thinking, you should be able to answer this one based off of the answers from the top two. Does a static member function have access to a class's instance variables? And I'll give a hint. Assume, all right. This question needs to be rephrased. Assume that an object is not passed to the static member function. Does it have access to the instance variables? Assume that the static member function is not passed an object of the class. Does it have access to the class's instance variables? All right, so 420 got it right. And attacker and flyer, I will say yes. I will say yes to that. But yeah, I just want you to kind of want to point that out. It's kind of hard. Let me pretend we had this. Say I made static container. I'm just making a fun little function here. Let's pretend that it's going to take two of these. So pretend we have this static function add 2. And here's the point I'm trying to make. And here's why here's why everyone's kind of right. I need to rephrase that question, and I will. I will try to make it as not ambiguous as possible. And I'm going to make it vertical so we can see what's passed to this function. All right. So if I'm in here and I type iPointer, this is the instance variable. In this case, no, the static member function does not have access to this. It's going to say, which one? Which one are you talking about? But because this function belongs to the class, if I wanted to access it from within an object, that's completely legal. All right, so you guys understand that, right? Everyone that kind of responded there is correct. But if not given an object, it does not have access to the variable. So once again, I'm going to rephrase it, and I'm going to provide kind of multiple answers for this so that you can study it and you won't be confused. All right, so there's a lot of class questions, and then they kind of shorten out here, but we're doing good. All right, so let's see if you guys understand this one. What operator would you use to provide a body for a member function outside of the class? If I wanted to provide a body for a function within a class outside of the class, what operator do you use? The scope resolution operator, right? Yes. If I want to provide a definition for a body outside of the class, I have to use the scope resolution operator. And the second thing I say, what else can you use it for? Well, you can use it to access members within the class, right? You can use it to access members within a base class. You can also use it to access static members, right? If I'm in main and I wanted to call that add function, let me see where I'm at. If I'm in main and I wanted to call that static function, I could say int container scope resolution. Look, I have access to this static. This is a static member function. So I can grab it. Because there's only one of them, right? There's only one of them, so I don't need an object. So you can use it there too. Now, yes or no for these, 11 and 12. If defining a const member function outside of the class, does the const come with? And if defining a static member function outside of the class, does the static come with? You guys remember this one? This one's in the notes too. And I kind of just did an example of this one, right? I kind of just did an example of that. So, not that you were paying super good attention, but we did just see an example of it. Does anyone remember? 11, yes, that is correct. 12, no, that is correct. Notice down here, I am declaring a static. The static does not follow it. Notice here, let's see. Maybe I didn't do any consts. I don't think I did. If I did something like int get int const, if I wanted to declare this outside of the class, I would come down here and I would say just like this, and the const that comes with it. But don't forget you need that scope resolution there, right? We need to put that there, and you're good to go. All right, so very good, very good. Where do we initialize static member variables? Global, I'm okay with that. Yep. Also, if you say outside the class's scope, I would say yes to that too. If it's outside the, well, you need to go inside of the scope of the class to reference it, but it must be initialized outside of the class definition. Global, I will give you full points for. If you say outside of the class, I will also give you points for that too. What does a constructor look like and when is it called? And can there be more than one destructor? 3 questions in one. What the heck am I doing to you guys? Let's start with the first one. What does a constructor look like? And when is it called? And if you guys are ahead of me, go ahead and answer number 15 too, because it's the exact same thing except for destructors. Class name, right? Flyer's right. The class name. It's going to be the class name and then whatever parameters are provided for it, right? Where's that? Right? Here's a constructor. What is it? It's the class name. Here's a constructor. Why? Class name. It's called when the object is initialized. And yes, there can be more than one. Right? What about the destructor? What about the destructor? And then number 16, I'll just speed run that one for you, since there's kind of a lot going on in there, and we'll finally move on to the next one. We are doing pretty good here on time. Yeah, we are doing good on time. Thank you all for answering these questions. Trying to make this an interactive class, you know. Sarah, you're right. It's the tilde and then the class name. Can we have more than one? That's my next question. Sarah is right. It has a tilde, class name. It's called upon leaving the object scope, and there can only be one destructor. That's right. That's correct. Now, if I wanted to be picky, the destructor is also called here, right? But if you wanted to, that's when it's deallocated, all right? So like I said, I won't be that picky on the test, but recall, if it's a static variable, then yes, or a stack dynamic variable. I won't talk about that. I'm just being OCD. But if it's a static variable and it leaves the scope, the destructor is called. If it's a dynamic variable and delete is called, then the destructor is called. Once again, I won't be picky about that on the test, but maybe on the final I will. All right, and then lastly, I say how to use the inline method in a constructor. I'll show you that, but let me see if you guys can answer this one. Compared to initializing variables in the body, is there a difference when using the inline method? If so, what is it? So I'll kind of tell you what I'm talking about here. Let's see where I'm at. So pretend I'm here in the default constructor. This is the inline method, right? The inline method is done like this. I put a colon here, and then I initialize variables out here. But reckless, got it, you're right. I'm saying, what is the difference between doing this and doing this? The difference is that, exactly what reckless said. If I do it up here, iPointer gets initialized before the body executes, almost before the the constructor is called. Now, of course, the constructor will be called, which kicks this off, right? So the main idea is that this gets initialized before the body, right? So there is a difference, and that difference is exactly that. It gets initialized before the body. All right, so now we're moving on. Does anyone want me to go back into the classes stuff and talk about that? That's pretty much everything you need to know for classes. And if you can know these, then chances are you can answer the test questions as long as you know how to code them too, right? As long as you know what the syntax for these things look like. So let's move on to inheritance. Let me know if I need to go back. Here's what I'm going to say. What does composition mean? And is it has a or is a? You don't have to do the example sentence if you don't want to. I'll give you one. But what does composition mean? And is it has a or is a? And then while you're at it, if you want to move on to number 2, go ahead, right? It's just the other one. What does inheritance mean, and is it has a or is a? I feel like I'm speaking, what is it? What is that language that we all did when we were kids? Where we like took the first vowel and put it at the end. Does anyone know what I'm talking about? You could like change English and you would speak to your friends by, let me know. But I'll go ahead and continue answering these questions, right? So Cherry got it, and so did Z. Composition is a has a, right? And what does it mean? It means a class is contained within a class. It's Pig Latin, that's right. Allie knows what I'm talking about. Pig Latin, that's the one I'm talking about. That's what I feel like I'm speaking when I say that. Is it has a or is a? Anyway, a composition means that a class contains a class, right? And Ali gave us the example. A cat has a leg, right? A cat is not a leg, but a cat has a leg. But then in inheritance is a, right? Meaning that one class is based off of another class. The example sentence of that is cat is a mammal, right? I was never fluent, but I could do it slowly. Can anyone tell me what it means for a member to be protected? If a member is protected, what does that mean? Remember, protected is a member access specifier. So somewhere in here in the class, I have private, I have public, and I might have protected. I also have to spell it right. Attacker says protected means only the base class and the inherited classes have access to it. That is correct. It can be accessed by the class and the derived classes. That's correct. What do I mean when I say super private? Do you guys remember that? What does that mean? What does that mean? If a member is super private, what does that mean? This is my term, all right? You're not going to Google this. You can't find it in a book, but I am going to test you on it. What do I mean when I talk about this? Let me see how we're doing. We're doing good. We might speed run here pretty soon. Give you a few more moments here. I know. All right, so Cherry says it cannot be accessed by the derived class. That is true. My full point test answer would be a class has this variable. A derived class has this variable, but it cannot access. Yes, attacker's right. Private member in the base class. That's exactly correct. A super private member in a derived class is a private member in a base class. That's a full point answer as well. Nice job. I ask you, what is the syntax for inheriting? I won't make you do that one, but if I wanted... I'm a little confused on that one. But what is the syntax for inheriting from, say, int container? Well, I would say class derived, and then I use a colon, and I would put it there. If I wanted to specify something, an access specifier, I might put it here. That's the syntax for that. So I ask you, this one you're going to probably review on your own. What are the three inheritance options, and what is different between them? Well, I'll just tell you quickly, and you're going to want to write it down. It'll be in the answers, right? But if we inherit publicly, that means that public members stay public, private members become super private, and protected members stay protected. If we inherit protected, that means public members become protected, protected members stay protected, and private members become super private. If we inherit privately, then public members become private, protected members become private, and private members become super private. You guys can answer this one. If no member access specifier is specified in the inheritance, what is the default? What's the default? If I had this and I said, nope, I don't want that, what is the default? Synchro, I'm sorry to hear that you're delayed. I understand. I think a lot of us are delayed, and I said we were doing good on time, and we still kind of are, but I am going to kind of speed it up here pretty soon. No, I do not want to buy followers. Thank you for not asking me about my feet, though. That honestly is way better than what we dealt with yesterday. So what's the default version? What does this say? You guys got to know this one, right? And after this one, I'm going to speed run. I'll give you one more chance for your participation here, and then I'm going to speed run. Little Tacker says public. I say no, that's not correct. It is private. Default is private. Think classes. Default is private. That's what it is. That is in the notes as well. You can go find that. Default is private. All right, it's speed running time. Please tell me if I need to go back. I'm sorry about this last bit. Tell me once again if I need to go back, and try not to fall asleep. I'm just going to kind of run through these things. What is a function override? Well, that is when a base class and a derived class contain a function with the same type, the same name. Well, it might not contain the same type, but it will have the exact same name, and it will have the exact same parameters. Same name, same parameters. Same name, same parameters. One's in a base class, one's in a derived class. If you wanted to access the base class version of a function override from the derived class, how would you get it? Well, that's kind of something we talked about up here, right? Let me find it. What operator would you use? We use the scope resolution operator, right? So if I'm in the base class and I want to go, if I'm in the derived class and I want to go up to the base class to get a version of a function, I can use the scope resolution operator. Scope resolution. Are derived class objects also instances of base class objects? No, they are not. Wait, yes they are. Yes they are. I'm getting ahead of myself. Derived class objects are also instances of a base class object. So if I say, is a mammal a mammal? Yes, it is. Is a cat a mammal? Yes, it is. Is a player a player? Yes, it is. Is a survivor class a player? Yes, it is. Are base class objects also instances of the derived classes? This one is where I was getting ahead of myself. This is no, right? Mammals are mammals, but mammals are not cats. If I said a mammal is a cat, that is incorrect. Inheritance is one way. It's one way, and it's down. Mammals are not cats, but cats are mammals. Can a derived class inherit from multiple classes? If so, what is the syntax? Yes, it can. It can inherit from multiple classes. It might look like this. The syntax is comma, right? Public, whatever the next class is, right? So here's the derived class. On the right side, you're going to have class 1, class 2, class 3. You can just list them off. What is one word to describe the problem of multiple inheritance? I briefly touched on this with the example with the Petrowski and the Lopez, if you remember that. The problem is ambiguity. Things are ambiguous. If I'm going to access my origin from the bottom of that diamond, you remember the diamond, if I'm going to access my origin from the bottom of that diamond, am I accessing the Petrowski origin or am I accessing the Lopez origin? So the one word I use for this is ambiguous. It is ambiguous. When you create an object of a derived class, the derived class constructor is called? Is the base class constructor also called? Which one is first? Well, yes. If I create a cat, the mammal constructor is called too. Which one is first? Well, the base class constructor is always first. The base class constructor is always first. Now, I do want some participation. I think we're moving along here a little bit. Can someone answer 16 for me while I'm describing number 15? If I wanted to specify which base class constructor, how would I do it? Can you guys answer that one? If I wanted to specify which base class constructor, how could I do it? While I'm waiting for that, I'm going to talk about this one, which is just the opposite of the other one. When you destroy an object of a derived class, the derived class destructor is called. Is the base class destructor also called, and which one is first? So remember that this is yes. If we destroy a cat, the mammal destructor is also called. But remember that a cat is based off of a mammal. A cat is based off of a mammal. A cat is based off of a mammal. And so the constructor goes mammal, cat, and then the destructor goes cat, mammal. All right? So the derived class destructor is called last. And then Cherry got it right. If I wanted to specify the base class constructor, how do I do it? I use inline method. You remember that? I use the inline method. You're going to do the inline method in assignment 3. You are going to use the inline method in assignment 3. It's a requirement. All right, so now we're on this last little bit. We've got 12 minutes, 1 page left, so we're going to move through this because we already talked about this pretty recently, so you guys should know this, all right? I'm just going to kind of read through it. What operator is used to get the address of any variable? Well, that is the ampersand, right? That's the and. Is it here? I may have deleted it. Yeah, I did. We use the ampersand, right? What operator is used to dereference an address? Well, it's the star. But if you also put arrow or bracket, I will not be mad. But the very, the most basic version of a dereference is the star. All right, it's the star. How can you get the size in bytes of a variable object, a variable or object, or a type? The answer of that is size of, right? We call size of. We're gonna say size of whatever the type or the object is. How do I allocate memory for a single object into a pointer? Provide an example using an int. All right, what's that look like? Well, here it is. There's my example. iPointer equals new int. This is the line. This is how I allocate memory for a pointer using an int. The next thing I ask is, how do you deallocate memory for a single object using a pointer? Provide an example using the same pointer from above. Here it is, delete iPointer. If you guys wanted to go above and beyond, avoid the alias. If you wanted to go above and beyond, avoid the alias. Right? Delete. So these next two questions are exactly the same, except for arrays. How do you allocate memory for an array of objects into a pointer? Well, let me pull open that example. By doing this, I call new with brackets. New with brackets. New with brackets, okay? How do I deallocate memory for an array of objects using a pointer? I call delete with brackets. Delete with brackets. All right. What are two methods of accessing an element at index I? I told you that would be a test question. How do I do it? Well, here are my two methods. Once again, tell me if I need to stop and go back on something. But we did go over these. Here's method 1, here's method 2. They do the same thing, right? Same thing. What is a memory leak? How is it avoided? A memory leak is an address that is not returned to the free memory. It's not returned to the operating system. How is it avoided? By calling delete. All right, that's the simple answer for that. How do you avoid memory leaks? Call delete. If you forget delete, you're going to have a memory leak. That was a little Dr. Seussy there, wasn't it? If you don't call delete, you'll have a memory leak. Delete and leak. Ask you, what is a dangling pointer? How is it avoided? Well, a dangling pointer is kind of this, right? Where is it? At this point, I have a dangling pointer. So if I have some code down here, and I say something like iPointer, blah, 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 you know, I dereference it or something, and I say equals 10. Notice that I haven't overwritten it, and so I have a dangling pointer because this variable still contains the address, and I still have access to it down here. So how do I avoid dangling pointers? By doing that. How do I avoid dangling pointers? By doing that. By overriding it, assigning null pointer into it. What is an alias? How is it avoided? An alias is when two variables contain the same address. So for example, here. At this point, I have an alias. Old array and new array have the exact same address in them. Old array and new array have the exact same address in them. How do I avoid the alias? Just the same way I avoid the dangling pointer. I overwrite it. I take one of them and I say, I don't want you to be looking at this address anymore. I overwrite it. I say, hey, you are now looking at null pointer, and now old array is the only address. It's the only pointer that contains that address. Now I ask you to explain deep copies and shallow copies, and I ask you to provide examples using code. Well, I'm going to open up Internet Explorer here. No, not Microsoft Edge. Internet Explorer. Because Internet Explorer is an exceptional program for loading PNGs. Did you guys know that? It's an exceptional program for loading GIFs and PNGs. Look at how big it is. Here's an example of a deep copy, right? What do we always do in a deep copy? We allocate more memory. What do we do in the shallow copy? Look how fast that was. That was faster than Microsoft Photos could do it. That was so fast. Look at this. I know I'm sidetracking. Look at how fast that is. This is where Internet Explorer is amazing. A shallow copy is when we assign... A shallow copy is by definition an alias, right? A shallow copy is when we alias them. We say pointer 2, you're equal to that address at pointer 1. That is an alias. That is a shallow copy. And the examples of the code are in that image, in those images. These images are on Web Campus. These images are on Web Campus. You can go find them. All right, so we're coming up on the end here. Suppose you have a pointer to a class object and you want to access a public member inside of that object. This is something we covered today. How do you do it? Here's method 1. Here's method 2. Right? What am I missing here? I gotta get rid of this. I'm gonna clean up this code and upload it to Web Campus where it will compile. But here's method 1, right? Dereference it and then call the dot. Or I can use the arrow. Dereference dot or arrow. Once again, that's the answer to 13. What is this when using classes? Well, I gave you that exact definition. This is a pointer to the object that the non-static function was called from. What operations are legal on pointers? Well, that's plus and minus, right? Plus and minus, addition stuff. Last two questions. What do you consider when using the rule of three? Let's see if you guys can answer these ones. These are the last questions here. We've got 3 minutes left. I'll let you guys participate since I kind of got it in here under the wire. To start, when do you consider using the rule of three? Does anyone remember what I said yesterday? When do we consider using it? What's the requirement? And if you're ahead of me, what three things are they? When do you consider using it, and what three things are they? I know some of you were hoping I was just going to read this one off. But, you know, I lie all the time. Cherry says when there's a pointer in the class, right? Exactly right. When do you consider using the rule of three? When I have a class and it has a pointer in it. If it has a pointer, I need to consider that. Do you remember what three things they are? It is the assignment operator, it's the copy constructor, and it's the destructor, right? You remember that? I even said it here, rule of three. It's the destructor, it's the copy constructor, and it's the assignment operator. Anything to do with the assignment operator besides just naming it will not be on the test. I'm going to ask you to name what this is. I will not ask you to provide, I'm not going to ask you to code it or anything like that. Pretty much that will be the question you'll see. What three things are they? And lastly, I'll answer this one for you. What two things are you attempting to prevent by providing definitions for these three things? Well, I will tell you. The destructor prevents memory leaks. This prevents memory leaks. These two prevent shallow copies or aliasing. Either one you want to use. This prevents memory leaks. This one prevents shallow copies and or aliasing. And that's it. That's the whole review. And we did it. Do you guys have any questions? Please let me know. I hope this was helpful to you. That's why I do it. Today, all of the answers for these are going to go up in the same kind of format. They're going to go up. They're going to go up in two separate documents. This review is going to be the same. This review is going to be the same, but it'll be a separate document for the answers, all right? So you can reference that. I hope you guys have a wonderful rest of your Friday. Please study this weekend. Please do assignment 3. Please do assignment 3. I promise you, it's not that hard. If you're confused, ask a question. We'll get you moved on your way so you're not stuck. And that's it. So you're free to go unless you have any questions. As always, I'm messageable. Sometimes I'll respond, sometimes I won't. You know how it is. It is the weekend. I may be dancing. Actually, I will be dancing this weekend, so just keep that in mind. And that's it. So I'll just hang out here for a little bit if you guys want to talk to me in the chat. Otherwise, you're free to go. You're welcome, attacker. You're welcome, little attacker. Thank you for coming to class today, and thank you for participating. Thank you, Sarah, for participating. Thank you, Flyer. You're welcome. You're welcome. Ugh. You're welcome, Z. You're welcome, Allie. You're welcome, Cherry. Thank you. All right, guys, I'm going to cut the stream. Send me a message if you need.